Hello guys, today I propose a solution of the exercise 14 of the chapter counting. So let E be a set such that its cardinality is equal to n. N is a natural number, and the first question is calculate the sum of the cardinalities of all the subsets of E. I'm going to call S this sum, and S is equal to the cardinality of a subset can be 0 or 1 or 2 or and so on until n. So the sum of the cardinalities of all the subsets is the number of sets that contain 0 element multiplied by 0 plus the number of sets that contain 1 element multiplied by 1 plus the number of sets that contain 2 elements, and so on until number of sets that contain n elements multiplied by n. And the number of sets that contain 0 element is n choose 0. The number of sets that contain 1 element is n choose 1, then n choose 2 until n choose n. Hence the S is equal to the summation of k is equal to 0 to n of n choose k multiplied by k. And to simplify this expression, I'm going to make disappear k, because I would like to show up binomial theorem. So I would like to transform this expression to show up a binomial coefficient. So I calculate inside n choose k is equal to factorial n over factorial k n minus k factorial n minus k multiplied by k, and factorial k is equal to k multiplied by k minus 1 factorial k minus 1 if k is larger than 0, and then we get factorial n over k minus 1 factorial k minus 1 factorial n minus k. And here in factorial n minus k we're going to show up k minus 1 because we can write that n minus k is equal to n minus 1 minus k minus 1. And then it's interesting because here we have got k minus 1, k minus 1, and then we are going to transform n. We can write that factorial n is equal to factorial n minus 1 multiplied by n and then it's equal to n multiplied by n minus 1 factorial n minus 1 factorial k minus 1 factorial n minus 1 minus k minus 1. And this is okay, because here we have a binomial coefficient which is n minus 1 choose k minus 1. Then we can come back to the summation here, and we have got the summation of n minus 1 choose k minus 1. K is going from we can start from k is equal to 1, because if we isolate the term corresponding to k is equal to 0, anyway it's equal to 0. And then we can factor by n in this summation. And here we begin to recognize a binomial theorem, and we are going to change of index. I put j is equal to k minus 1, so I get the summation of j is equal to 0 to n minus 1 j, and thanks to the binomial theorem we get n 1 plus 1 to the power of n minus 1. Is equal to n2 to the power of n minus 1. The second question is let p be a natural number such that p is less or equal to n, and let A be a subset of E such that its cardinality is equal to P, and the question is calculate the number of subsets of E that contain exactly one element in A. So to build a subset of E that contains exactly one element in A, First we're going to choose an element in A. Construction of such subset. First I choose one element in A. I've got P possibilities. And secondly, I choose some elements in E minus A. And how many possibilities are there? The number of parts that I can build, the number of subsets of E minus A is 2 to the power of the cardinality of E minus A. So is equal to 2 to the power of n minus p. So here I got 2 to the power of n minus p possibilities. And then hence the number of subsets of E that contain exactly one element in A is the product of the two numbers p 2 to the power of n minus p. The third question is calculate the cardinality of the power set of E square. And here we know that the cardinality of the power set of E square is equal to the square of the cardinality of the power set of E, and then we know that the cardinality of the power set of E is 2 to the power of n, and then we get 2 to the power of 2n.